So let's look at an application of some linear equations. So we want to graph the winnings. So the equation y equals 10 hundredths x, or 10 hundredths times x, plus 200, describes the amount of winnings a group earns collecting plastic jugs. And this is going to be in the recycling contest that they were doing. So it says sketch the graph on the coordinate system. So notice that when you create a graph, a lot of graphs, all you're really going to need is that first quadrant. Those other quadrants aren't even really relevant in real-world problems. So a lot of times when you see a graph, all it's really going to be is just a blown up of the first quadrant because the other three quadrants aren't really necessary. Notice how the x-axis is going to be our, looks like it's in pounds. So that sounds like the plastic jugs, how much we're collecting in pounds. So it looks like this is going to be 500 pounds, 1,000 pounds, 1,500 pounds, 2,000 pounds, so forth and so on. And keep in mind, if you ever play around with collecting plastic, these are the kinds of numbers you're talking about. You're going to be talking about a lot. So it's not going to be a good idea to make a scale that goes about 1 pound, 2 pound. So when you create scales, it's got to have to kind of relate to how your numbers look up. So notice how our incomes from the recycling, $200, $400, $600. So notice we're going to have to collect a lot of plastic to have that play out. So to make my graph, I got to pay attention to my x values here. There's no need to be picking 1 for x because my graph doesn't show that. So I really need to be picking x's based on what my scale is here. So when I write this equation, y equals 10 hundredths x, I'm going to write that as 10 hundredths x plus 200. Also, I can reduce this down to 1/10 x plus 200. Now, if you have a calculator, you probably don't have to do this. So I don't have a calculator. I'm going to make this math a little bit more meaningful because I know that a tenth essentially just means to divide by a 10. So that math is going to work out for me. So let's just start with some x values that are relevant to me. So let's start with that 1,000. So that 1,000 is going to be my x value. So it's going to go in place of x. So I'm going to have y equals 1/10 times 1,000 plus 200. So let's again, since the equation was written in this form, I like that method of finding those 3 solutions to graph the equation. So my first solution, I'm going to just use 1,000. So when we use 1,000, we know that dividing by 10 makes me just lose the place value. In other words, drop off a 0. And that's going to be 100 plus 200. So it's going to give me 300. So if x is 1,000 pounds, I'm going to earn $300. And let's choose, let's just go across here. Let's just choose 2,000 to make this math easier for us. So again, it was really important to pay attention to the table. That helped us understand what values actually pick for x. So we have y equals 1/10 times 2,000 plus 200. Again, a tenth, or dividing by 10, will drop off a 0. And that's going to be 200 plus 200, which in turn is going to give me 400. So if I collect 2,000 pounds, I'm going to go up to $400. And you can kind of see that my next move is going to probably collect 3,000 pounds. And notice here that it went from 300 to 400. I bet you this will probably increase another 100. That probably will be 500. Let's play that out, because a lot of times, sometimes you don't even have to do the math. You can see the pattern, especially with linear equations. They have this constant change going on. If I'm doing a constant change over here, if I'm changing by 1,000 each time, these y values should also have that same constant change. That's going to be a relationship that goes on with linear equations. But let's go ahead and verify this 3,000. So I'm going to have y equals 1/10 times 3,000 plus 200. That was my original equation. Oop, that's got to be a tenth there. So y equals 10 goes into 3,000. That's going to drop off a 0. That's going to be 300 plus 200. And that does indeed give me my 500. So when I put 3,000 pounds in, I'm going to get $300 out. So they asked me to just graph this. So 1,000 gave me $300. 2,000 gave me $400. So 2,000 gave me 400. And then 3,000 gave me, that don't look like a 5. That should be looking more like that, 500. So 3,000 gave me a 500. Okay. So now I'm ready to sketch my graph. And we really don't have to go through this axis. We can kind of start at it. So I can get this all to line up for me. Graph looks something like that. The way this contest works, it looks like if you just show up, you're going to get a $200. Because that looks like that's what's happening here with this formula. You know, if I put x to be 0, if I don't need to collect anything, I'm going to have a $200 coming to me. So, strange little formula if you think of it in the real world. Not doing anything and getting paid, that was a little strange looking there. And then, now where it makes sense though is out here, you know, 1,000 pounds collecting 300, so that's kind of a strange point just looking at the data there. And that's what you have to sometimes do with graphs. Does the data make any sense sometimes? You just have to think that through. So keep that in mind as you start to apply math to things. Does the math make sense? Okay. So that was an example of graphing a formula that they gave us. And it turns out that that formula for calculating your earnings, your winnings, was a linear relationship. Stay tuned for more.